Welcome back to the chapter on kinematics. Today we will be attempting question 3. Without further ado, let's move on to the question. For question 3, part C is rather interesting. Now we will do it perhaps in a different way from some of your teachers. Now I personally prefer to interpret part C using a graph, and with the help of the graph we then work out the solution, which is much shorter compared to some of the methods that you are using. Particle Q is moving away from O, whose displacement is given by this expression here. S is equals to 6t squared minus t cubed. You are asked to find the velocity after 5 seconds. Now part 1 is rather simple. Now, velocity is you can get velocity by differentiating displacement with respect to time. So, ds by dt will be given by 12t minus 3t squared. Now, so your v when t is 5 will be equals to 12 times 5 minus 3 into 5 squared. This is 60 and this is minus 75. So your velocity will be minus 15 meters per second. Now in part 1 of the question, I think they also ask you to find the speed, alright, which I have missed out over here. Speed at 5 seconds. Now, but speed, there's no negative speed, alright. So for speed, it will be just 15 meters per second. Now because speed is a scalar quantity, it does not have negative speed. So you just take the modulus of velocity, you get speed. Now let's move on to B. You are asked to find the distance from O when it is instantaneously at rest after passing O. Now let's find out when does the object comes to an instantaneous rest. Now instantaneous rest means the velocity is 0. So what you need to do is you equate 12t minus 3t squared equals to 0. Then you can factorize. So 12 minus 3t equals to 0. And your t is equals to 0 or 4. So we find that it is at rest when t is equals to 4. Now, so let's sketch the velocity time graph. This is the expression for your velocity. So it cuts the x-axis or the t-axis at 0 and 4. So it is a maximum graph because it's a negative t squared. So this is 0 and this is 4. Now you are asked to find the distance from 0 when it is instantaneously at rest. Now, so what we need to do is we can find the displacement, alright, because it's a distance from O. when it is instantaneously at rest. All right, so what we can do is to find the distance from O, we just substitute t equals to 4 into your displacement expression. So S4 will be given by 6 into 4 squared minus 4 cubed. And what is, you punch this into the calculator, you will get 32 meter. All right, that is your answer to part B of the question. Now let's move on to C. Now you are asked to find the distance traveled after 5 seconds. So let's say, assuming that 5 is here. So you are asked to find this distance, all right? It has traveled over here, covered here, as well as here. Now, what does this point when t equals to 4 represent? All right, this is a point where it U-turn. Because the polarity of your velocity changes sign. It changes from positive to negative. That means it is traveling in the opposite direction as from the start. All right, when the velocity is negative. So for t equals to 0 to 4, so from t equals to 0 to t equals to 4, the distance traveled is how much? Distance is equals to 32 meter. All right. Now we need to find the distance traveled from the 4th second to the 5th second. To find the distance traveled for the from 4th to 5th second, what we need to do is we integrate. All right. You integrate your V, is the area under the graph, VT graph, from 4 to 5. But because it's distance, so there's no such thing as negative distance. So we need to take the modulus of it. All right. So if we integrate your V, you get your this S expression. All right. So it will be 6t squared minus t cubed from 4 to 5, all right? But you must take the modulus of it. So if you substitute this, you get 6 into 25 minus 125, all right? That is when you substitute t equals to 5 into this expression. Then you must minus the value when t is equals to 4. You substitute 4 into this expression. But we found earlier that this value when t equals to 4 is 32. So you minus 32. All right. Then we do a close bracket and you must take the modulus of it. Now, if you key this into the calculator, you will get a value of 7, all right, or minus 7, but you are taking the modulus of it, so you get 7 meters. Okay. Now, therefore, the total distance will be 32 plus 7. All right. So, therefore, total distance covered from 0 to the 5th second will be equals to 32 plus 7, and then you get 39 meter. Okay. For that, we have come to the end of this question. In the next video, we will be working out this particular question. This question is taken from the IB examination, November 1917, question 5, time zone 0. This question entails a lot of concept within the question. In any case, we will be working out the detailed solution. And I will be putting the URL link in the description below. We hope to see you again. Thank you for watching. Have a nice day.